Alright, part 2 of our Conics sections unit is talking about ellipses. Ellipses are a lot like circles, and they work in a very similar way, except they're kind of like a squashed circle. Now, the way I usually first start talking about about ellipses, is by comparing it to a circle. So let's say we had the circle x squared plus y squared equals 5 squared. So here we have that circle centered at the origin. And we have our equation x squared plus y squared equals r squared. Now what I want you to do is I want you to take that r squared value and I want you to divide it on both sides. So on the left, we'll have x squared divided by 5 squared plus y squared divided by 5 squared equals 1, aka 5 squared divided by 5 squared. Now this looks a little different than how you've seen the circle so far, but all we've done is divide everything by 5 squared, so it has to be totally valid. Now the way I read this equation when it's written in this form is I look at that 5 squared underneath the x, and I take that to mean from the center, go 5 to the right, and go 5 to the left. And then I look at that 5 squared underneath the y, and I take that to mean from the center, go 5 up, and go 5 down to get all those points. So imagine I had an equation that was similar to this, except they weren't both 5 squareds underneath. Maybe they're different values. So what if my equation said this, x squared divided by 3 squared? Well, first off, notice my center is at the origin because I don't have anything add or subtracted from x or y, just like a circle. So I read that 3 underneath my x as telling me to go 3 in the x direction to the right, 3 to the left. I look at that 4 and I see that telling me to go 4 up, and 4 down to get all these points. And once I have those points, all I have to do is draw in the resulting shape, which is an ellipse. It's like a circle, except the horizontal distance away from the center and the vertical distance away from the center are not the same. But you'll notice graphing it worked essentially the same exact way. So what is an ellipse? Well, an ellipse has a more technical definition than just what we saw right there. The technical definition of an ellipse is the set of all points x comma y whose sum of the distances between that point xy and two fixed points called the foci is constant no matter where you look. So what we're saying is, imagine we have that point xy on the ellipse right there. That length d1 plus d2 has to be the same as any other point we choose on there. So imagine I choose a point like right here. What we're saying is that d1 plus d2 has to equal d3 plus d4. The sum of the distance from the point to each focus is constant for every single point on this ellipse. Every single point you look at, even if you're perfectly to the right, if you look at this point, then that distance right there would be, we could call that d5, and then the distance from this point right here all the way over to that other focus, call that d6, we're saying d5 plus d6 has to be the same as all those other d1 plus d2s and d3 plus d4s. It's constant for every single point on the ellipse. And that's a fairly technical definition, but we saw how simply it works out if you have the equation in a nice factored form. So let's maybe look at a labeled version of an ellipse. Now, just like a circle, it has a center, which we call h, comma k. Now the vertices on an ellipse are going to be the points either horizontally in line or vertically in line with that center, whichever is farther away. So this distance right here out to that vertex is denoted by the value a. Now if we look at that distance from the center straight up to the co-vertex, we call that distance b. And yes, there are two vertices and two co-vertices. But additionally, we have those points in the middle called the foci. We have one focus In this example, to the left of the center and one focus to the right, we have two foci. And the distance from the center to a focus is called C. Now the other important pieces we're going to look at is the distance between the vertices. That is called the major axis. And notice if it's from the center to one vertex is A, then from one vertex to the other vertex has to be 2A. And similarly, you can look at the distance between each co-vertex, and that is not the major axis, but the minor axis, and that is denoted by 2B. Now this is the basics of an ellipse right here. There's a relationship between A, B, and C that you can discover. We're not going to get into that right now. We're going to start jumping into how we can play with an ellipse. But we should probably talk about what the actual equation is. Oh, and quick note, you can absolutely have a vertically oriented ellipse as well. It just means that the major axis is running up and down. It just means the longer piece is going up and down instead of side to side. It really doesn't change how the equation works as well. It changes whether or not A is sideways versus up and down and B, etc. But it doesn't really affect much else. So let's look at the equation. Notice it looks just like the circle equation when we divided that r value down, except we have different r values for horizontal and vertical, essentially. X minus h squared over a squared plus y minus k squared over b squared equals 1. When our ellipse is factored, we always set it equal to 1. We're not finished until it is equal to 1. So that's technically the equation of a horizontal ellipse. If I wanted a vertical ellipse, I would just swap A and B, and that would be that. Now let's look at some problems where we can actually use this.